In order to make the tunnel work properly, ensure the safe passage of vehicles. In addition to main structures such as portal, open-cut tunnel and tunnel lining, some auxiliary structures are needed, such as refuge recess, firefighting facilities, emergency communication facilities, waterproofing and drainage facilities, lighting equipment and ventilation structures. In this lesson, we will focus on the ventilation structure and refuge recess. First, let's learn about the ventilation structure. Ventilation structure: it discharges harmful gas, heat, humid air, etc. out of the tunnel, and inhales fresh air into the tunnel, to make the air in the tunnel harmless, so that the train crew and maintenance personnel in the tunnel can work comfortably and efficiently. The tunnel ventilation shall meet the requirements of the current Code for Design of Railway Tunnel. It makes use of natural airflow in the tunnel. There is natural ventilation and mechanical ventilation, and piston air during train operation. To achieve the purpose of ventilation, it is to achieve the purpose of ventilation by a series of ventilators to feed or exhaust air when natural ventilation cannot meet the requirements. So how do we arrange mechanical ventilators? Depending on the direction of the air in and out of the tunnel. Mechanical ventilation involves longitudinal ventilation, full transverse ventilation and semi-transverse ventilation. The first is longitudinal ventilation. That is, the air flows along the direction of tunnel axis under the action of the ventilator. There are 4 ways to achieve airflow along the tunnel axis direction: air passage ventilation at the portal, nozzle ventilation, shaft ventilation, and jet ventilation. Let's have a look at the air passage ventilation at the portal. That is, the ventilator is installed at the tunnel portal to connect the ventilation duct to the tunnel. When the train just leaves the portal, the ventilator will be started immediately. Expel the dirty air that has been pushed into the exit section by the piston air out of the tunnel, and the fresh air outside the low portal is brought into the tunnel with the airflow. In this way, a ventilation operation is completed. For nozzle ventilation, an air chamber is built above the lining at the tunnel portal to collect fresh air. At the end of the chamber, an annular nozzle is made on the periphery of the lining leading into the tunnel. When the fresh air outside the tunnel is pumped by the ventilator to the air chamber, and when air builds up to a certain pressure, it is sprayed into the tunnel from the annular nozzle around the lining at a very high velocity and a very small angle. Shaft ventilation. When the longitudinal section of a long tunnel is a herringbone slope, dirty air often accumulates at the top of the slope, resulting in poor ventilation. If shafts or inclined shafts are provided as service galleries in tunnel construction, these service galleries can be used as ventilation ducts. The ventilator is installed in the shaft or inclined shaft. Therefore, dirty air is extracted, or fresh air is inhaled by the ventilator in shaft. Jet ventilation. Jet fans are arranged in the tunnel to ventilate by increasing the air pressure in the tunnel. The next is the full transverse ventilation. That is, airflow is orthogonal to the tunnel axis under the action of ventilator. It can evenly blow in fresh air along the full length of the tunnel, while dirty gas will not flow along the full length of the tunnel and will be directly sucked out via the air inlet in situ. So the ventilation is ideal. However, it takes up tunnel clearance and is more complicated in structure. Finally, semi-transverse ventilation. That is, the air inlet pipe is arranged at the top of the tunnel, and at the lower part of the air inlet pipe, a ventilation opening is made every a certain distance along the length direction of the tunnel. The airflow flows into the tunnel along the ventilation opening, and then the air in the tunnel is driven out of the tunnel by fresh airflow along the longitudinal direction of the tunnel. Refuge recesses refer to caverns built on sidewalls on both sides of the tunnel, in a staggered and even manner for refuge and storage of vehicles and materials. Refuge recesses are also essential tunnel auxiliary structures. There are large refuge recesses and small refuge recesses according to the size of their sections. The clearance dimension of the large refuge recess is 4 m wide. The recess sidewall is 2.5 m deep, and the center is 2.8 m high. In the tunnel with ballast bed, a large refuge recess is arranged every 300 m on each side. In the tunnel with concrete broad sleeper ballast bed, or monolithic ballast bed, a large refuge recess is arranged every 420 m on each side. In the tunnel with ballast bed or monolithic ballast bed, a small refuge recess shall be arranged every 60 m for single track and every 30 m for double track. The refuge recess is provided for temporary refuge of maintenance personnel. So the following structural requirements shall be satisfied. The refuge recess shall be built simultaneously with the tunnel lining to ensure structural continuity. During construction, the expansion joints, settlement joints, construction joints, and joints of different types of linings or different widened sections shall be avoided. In addition, the bottom surface of the refuge recess shall be flush with the ballast bed or the cover plate surface of side ditch, so that maintenance personnel and trolleys can enter smoothly. Finally, it allows the location of the refuge recess be visible, easy to find it in the dim tunnel. In addition, the tunnel auxiliary structures also include waterproofing and drainage structures, including drainage ditch and blind ditch. Design standard of tunnel waterproofing and drainage. The lining is not dripping, and the holes where the equipment is installed shall be free of water seepage. The ballast bed shall be free of accumulated water. The arch of electric traction tunnel is hardly permeable to water. First, let's learn about the drainage ditch. The section size of the ditch depends on the discharge amount. Generally, the bottom width shall not be less than 40 centimeters, and the depth shall not be less than 35 centimeters. The longitudinal slope of the ditch bottom should be consistent with the track slope. If not, the longitudinal slope of the ditch bottom shall not be less than 1 per thousand, and the transverse slope of the ballast bed bottom shall not be less than 2 per thousand. Next, let's learn about the blind ditch. Behind the lining, a circumferential or vertical blind ditch for flowing water is built with rubble, pebbles or buried pipes to collect groundwater around the lining, including blind ditch with spring hose and blind ditch with chemical fiber infiltration cloth. In addition, waterproofing and drainage structures also include aqueduct, waterproof layer, waterproofing and drainage of tunnel roof, portal waterproofing and drainage. Finally, the tunnel auxiliary structures also include cable troughs, HV and LV power supply buildings, etc. Auxiliary structures of the tunnel aim to ensure the safe passage of personnel and vehicles. They are also important facilities to ensure the long-term safe service of the tunnel. We have learned the basic information about tunnel auxiliary structures such as ventilation structures, refuge recesses, and waterproofing and drainage structures. It will help us to complete the tunnel construction. Finally, in which case are natural ventilation and mechanical ventilation applicable respectively?